Hello all, hope you are doing good over there. I am Tirdesh. So today let us see what is this basic theorems of Boolean algebra. In my previous video, I have given all the things which are related to Boolean algebra itself. Say a truth table, about truth table, it's a mathematical table which provides us the proper values and representations, and logical gates, a gate, the representation of or input representation of the Boolean algebra, and many more. Basic postulates of Boolean algebra we have completed, and also we have completed on duality theorem also. Today let us see some basic theorems of Boolean algebra. So first there are some eight theorems in Boolean algebra. One is a properties of zeros and one, independent law, involution law, complementary law, commutative law, associative, distributive, and absorption law. So first let us see what is this properties of Boolean algebra. There are four laws in the Boolean properties of Boolean algebra. First one, it says if 1 is added to any of the inputs, then value will be 1. And 1 and 0 is added to any of the number, the value will be x. And next one is 1 multiplied with any of the number, it returns to me 1, and 0 is multiplied with any of the number, it tends me 0. So this is the four properties of 0 and 1. So for the first, let us prove how does this theorem acts actually. So say for the example, you have taken your value as x1 plus x is equals to 1. So then put x is equals to 1. So 1 LHS. So 1 plus 1 is equals to 1. So 1 plus 1 is 1 0. I am going to consider only the 1. So 1 and 1. So LHS is equals to RHS. So next was, so 1 0 plus any of the number. So 0 plus x, put now your thing is 0 plus x is equals to 0 plus x is equals to x. So how do you do? Put x is equals to 0. So 0 plus 0 is equals to x. So 0 is equals to x. So what we did, we put x is equal to 0. So what did it come? It came the value which you have given. So this is the second property. And third property is, if you 0 into x is equals to 0. So put x is equal to 0. So 0 into 0 is equal to 0. So 0 is equals to 0. So this is LHS and RHS. This is LHS and RHS. So now last one is, so 0 plus, so x1 plus or 1 into x is equals to 1. So put x is equals to 1 means 1 into 1 is equals to 1. So 1 is equals to 1. So this is LHS is equals to RHS. So this is how our first property looks like. So let us see how does this act actually. So suppose I am going to take the truth table now. So suppose x is equal to 0 or 0x 0 plus x. Check out now. So now 0 and x is also 0. Then 0 plus 0 is 0. 0, 1. Now x is equals to 1. So here, this is how a truth table works for 0 plus x. Now 1 plus x. So 1 x 1 plus x. So 1 0 1. 1 1 means 1. So both are in tautology, then this value is satisfied. And now you can see here also 0 plus 1 is 1 means whatever the value you are going to take for x, that value will be repeated back. So this is how properties of 1 works for OR table. How does the properties of 190 works for INT table is, so I am going to show you. Now 0 into x which is equal to 0. So how do you have to put 0 x 0 into x. So how does it get? First is again always 0. 0 is 0. 0 1. 0 into 1 is 1. So 0 into 1 is 0. So you get for tense value. Because here we are going to use a logical multiplication. For that reason you will get the value as 0. Next 1 into x is equals to x. So how do you write them? So the truth table for this. So 1x 1 into x. 1 into 0 0. 1 into 1 is 1. So this is the truth table for INT representation. So hope you all understood this. So when I do this, how I am going to write the equation for this, or how I am going to write the logical gate for this is, so for first one is 0 plus x is equals to x. So first my input there are 2. So I am going to work on binary theorems or binary values. So 2 to the power of 2 which is equals to 4 values. So 4 means 0 0. First I am going to write truth table for this. 0 0 0 1 1 0 1 1. So x y. So first I am going to do truth table and later I am going to show you the logical gate for this. So x 0 plus x. So x and y, right? X and y or 0. 0 and y. So x is 0 plus x. Okay. So now 0 into 0 is 0. 0 into 1 is 1. 1 into 1, 0 into plus 1 plus 0 is 1. 1 plus 1 is 1. So this is the proof, or I can represent till here itself. So I can also represent till here itself, only this much. So for truth table for this is, or logical gate is this is a OR symbol. So 0 x OR symbol. You want to write the OR symbol over here. So 0 plus x. So this is for 0 plus x. So 1 plus x is equals to 1. So how do you do this now? So now you can see over here. So truth table. One x 1 plus x. So 1 0 1. 1 and 1 means it is equals to 1. So to logical gate, I am going to represent logical gate. 1 and x. So 1 and x. So you get 1 plus x. So this is the logical gate for OR representation. So now a logical gate for INT representation is. So logical gate for INT representation is. So 0 into x is equal to 0. So first I am going to write the truth table. So 0 x 0 into x. So 0 0 0 1. 0 0 is a 0. 0 into 1 is a 0. So how do we write the truth table representation for this? First is 0 x. Here you have dot representation, means it is the INT representation. So I am going to provide the INT gate. So I am going to provide the INT gate. So 0 into x. So next is 1 into x. So what does it happen now? So you get the value, first the truth table. So 1x, 1 into x. So now first 1, 0, 0. 1 into 1 is 1. So how do you write the truth table logical gate for this? 1x. So AND gate representation. AND gate representation. You get 1 into x. So this is the properties of 0 and 1. So you get, if you write 0 and add 1, which is equals to 1. 1 plus 0 is equals to 1. 0 plus 0 is equals to 0. 0 plus 0 plus 0 is equal to 0. 1 plus 1 is also equals to 1. 0. 1. So first for AND representation, for OR you get this part. And when I use the AND, 0 into 0 is equal to 0. 0 into 1 is equals to 0. 1 into 0 is equals to 0. 1 into 1 is equals to 1. So in previous videos I have explained you AND, OR and NOT gates. So same way, when you are going to work with 0 and you use the OR gate symbol, and if you add 1, because Boolean algebra, Boolean means it says only two values, true or false. So here true is the high volt, which is equals to 1, false is the low volt, which is equals to 0. So here we are only represented working with two inputs like 0, 1, 1, 0, 1, 1. So the variables may change but the values may not change. So this is the properties of 0 and 1. So I hope you understood how does the properties works for 0 and 1. So next is independent law. So what does independent law say? A variable acts with the same variable using some logical gate symbol, then the value is 1 for OR gate and value is 0 for AND gate. So how do you say that now? Independent law. So it states that when a variable is combined with its same variable, using a OR gate or AND gate, x plus x or x into x, then the value will be same, x. So how do you do them? So now say for example, now put x is equals to 0 in first equation. So what does it do in 1? So 0 plus x is equals to x. So 0 plus x is equals to x. So now in second equation or in same input equation itself, put x is equals to 1. So what will happen? Now 1 plus x is equals to x. So 1 plus x is x. 1 plus x is x. So 1 plus x is 1, which is equals to x. So you have seen this. So anything 1 plus x, it gives me 1 itself. So previously I have explained in properties itself. So 1 plus x is equals to 1. So I am going to apply them here. So x is equals to 1. So what I have put, x is equals to 1. So therefore LHS is equals to RHS. So now for the second equation. So now what you do, you can check out for second equation also. So put x is equal to 0 in 2. So 0 into x is equals to x. 0 into x is 0 is equals to x. So what we have proved? We have taken x as 0, so x is equal to 0, so LHS. It is proved LHS is equals to RHS. So or you can take, put x is equals to 1 in 2. So put x is equals to 1 means 1 into x is equals to x. So 1 1s are 1, x is equals to x. So this is satisfied. So this is how our independent law works. So it states that a variable acts with same variable using some OR gate symbol or AND gate symbol, the value will be same. This is a independent law statement. So this is how your independent law looks like. So now if you write a logical gate for this. So how does the logical gate looks like actually? So a logical gate for this is, so now you have addition symbol over here, x and x. Addition means it is called a logical OR gate. So I am going to write the OR gate symbol. So which is equals to x. So OR gate symbol is like this, sorry. Is x. So now AND gate means you are going to represent by AND symbol. X into x with two variables are the inputs. AND gate. This is, so this is how a independent law looks like. So if you write a truth table for this, how does it look like? Now let us prove this equation through our truth table. So x and x, which is equals to x. So 0, x is 0 means again x is 0, then therefore x is equals to 0. Now x is equals to 1, by x again is 1, then x is equals to 1. So here you can see. So if I take a x value, the answer of the x value will be same. If I take a x value again, the answer of the x value will be same. Means if a variable is combined with the same variable using AND gate or OR gate or AND gate, then the answer which you obtain will be same. So this is the basic theorem or independent law theorem states. So next is involution law. So what does the involution law state? Involution law states a variable is negotiated or inverted again twice or two inversions. A variable, this law states that the complement of a variable is a complemented variable is complemented again. Means if x is a complement variable and if you complement that variable again twice, then your answer will be x. So how do I represent a logical gate? AND gate symbol means x bar means it is a AND gate or a negative gate. So x means this says x bar. Now x double bar. So x bar means like is this. Now x double bar means again you are going to write a AND NOT gate symbol and you are going to provide them. So which will be equal to x. So let us take an example. Let us take an example. So in example, put x is equals to 1. So x bar means is equal 0. So again x double bar means 0 double bar which is equals to 1. So x bar means 0 bar, 0 double bar means is equals to 1. So it will be the reverse, or I can say it is a reverse value. So now if you take x bar or x value as 0, so 0 double bar will be is equals to, so 0 means, so x bar is equals to 1. So again 1, again if you complement them, it becomes 0. So ultimately I can say x double bar is equals to x. This is the involution law. So hope you understood the involution law. So you can check out in the truth table also. So a truth table x double bar x double bar. So how do you write now? Now if you take x as 0, 0 bar is 1. Again if double bar means it is equal to 0. So now you take a x value as 1. 1 bar is 0. 0 double bar means it is equals to 1. So what you get the same value of x in the resultant column. So this is the involution law state. Means a complemented variable is complemented again. A complemented variable or inverted variable. If you invert a variable again and again, then you will obtain the same value which you have inverted. Or I can say the combination or a NOT gate. Involution law says that a variable states that a variable is complemented again and again, then we get the same variable. If the variable is complemented again and again, means double complement, then you get back the same variable. Means if you say x is equal 0, then x double bar is also equal to 0. If you say x is equal to 1, then x double bar is also equals to 1. So this is the involution law. So next is complementary law. So what does the complementary law say? A complementary law states that if a variable is complemented with the help of a gate if the help of AND gate or a OR gate, then you will get the value as 1. So for OR means you will get the value as 1. Means if a variable x is a variable and it is been complemented, means inverted, with addition, means it is a OR gate symbol, then you will get the option as 1. If x is a variable and you have inverted them using a AND gate, then your x variable will be 0. This is the complemented law. So how do you represent this complemented law? A complemented law is represented as, so x is the variable. Now again what you did, you have inverted this variable using a AND gate, means x bar. So what you will get the option? So here you have a OR gate symbol. So you have OR gate symbol. OR gate is written not like this. It is written as this is the OR gate symbol, you get 1. So if x is the variable, now x is a variable, again you have complemented this x variable with a AND gate. Complemented this x variable with the AND gate, then you will obtain the value AND gate, you will obtain the value as 0. It is equals to 0. So let us prove this statement. Now, say for the example, you have taken your x value. Say for the example, you have taken your x value, x is equals to 0. Okay. Now what happens is, now put x is equal to 0. So now x plus x bar. So 0 plus 0 bar is 1, which is equals to 1. So you have proved this. So now again, for example, you take the value, put x is equals to 1. So what you get now? So x is equals to 1 means, so x plus x bar. So 0 plus 1. So x is 1. 1 plus x bar is 0, which is equals to 1. So this is the proof for first equation. So same way you can prove the second equation also. So how do you prove that? Now take down the example now. See here, put x is equals to 0. So if you put x is equals to 0 in the equation, then what does it happen now? So x into x bar. So x is 0 into x bar is 1, which is equal to 0. Now if you see, put x is equals to 1. So 1 into 1 bar is 0, which is equal to 0. So this is called as a complementary law. So what does it say? A variable is being complemented. A variable is being complemented with the help of AND gate or OR gate. AND gate. So with the help of OR gate, then your answer will be 1. If you complement that variable with the help of AND gate, then your answer will be 0. So this is the involution law. So let us also try to prove this in a truth table also. A truth table. So what you will get? So x bar, x plus x bar. So x plus x bar. So now you see, x means first x is equal to 0. 0 bar is 1. 0 plus 1 is 1. Now again x is equal to 1. X bar is 0. 1 plus 0 is 1. What you obtain? You obtain the tautology. So remember, when you are going to work with OR gate symbols, you always get a tautology values. Now when you are going to work in a AND gate, you may get a mixed value. It may be tautology or it may be a false. So this is the example for tautology where x plus x bar is equal to 1. So now same variable with the, let us try out with OR gate, AND gate. So how does it work? AND gate means you should have a logical multiplication order. Means now if I say x is equal to 0, 0 bar is 1, 0 into 1 is 0. Now x is equal to 1, 1 bar is 0, 1 into 0 is 0. So this is the values for, this is the tautological values. So here this is called as a complementary law. Now let us see a commutative law. So all knows the commutative law. So commutative law is like it is used in a mathematical format in a set or algebraic representation. So what does it say? It says I have two variables x plus y. If I switch that variable into y plus z, I will get the equal data. Or I may say x into y, which is equals to y into z. So this is the commutative law. So how do you prove this commutative law? So you just check out. So put x is equal to 0. So 0 plus y is equals to y plus x into y is y into x. X into y is y into x. Y plus 0. So y is equals to y. Or put x is equals to 1. So 1 plus y is equals to y plus 1. So you know this you have seen in the properties of Boolean algebra. 1 plus y is always equals to 1. Or I can say any value which is added, used the OR gate and you have taken the value, then answer will be 1. So 1 is equals to 1. So this is a properties of commutative law. So you can also check for OR gate. So see, put x is equal to 0. So put x is equal to 0. So what you get now? So 0 into y is equals to y into 0. So which is equals to 0. Anything multiplied by 0, it will remains a 0. Now put x is equals to 1. So 1 into y is equals to y into 1. So y is equals to 5. So this is the commutative law. So how do you write the logical gate for this? So what does we have? We have two OR gate symbol and two AND gate symbol. So how do we prove this using a logical representation? So when you are going to use a logical representation, like you have x plus y. So two inputs x and y. So in middle you have OR gate symbol, OR gate symbol, OR gate symbol. So x plus y. So which is equals to, again it becomes y and x. Y and x. So y and x is also a OR gate symbol. So it becomes y plus x. So this is how you are going to look in a logical OR gate. Now if I write a logical AND gate for this same equation, means so x and y. So you have two inputs, AND gate, you get x into y. So the result will be is equals to two AND gates y into y and x, y and x, the result will be is equals to y and x. So this is how we are going to represent in a AND gate. So check out the truth table for this. So when you are going to work on a truth table, make sure you should check for how many variables are there. So when you have two variables, what you should take? So 2 to the power of 2, which is equals to 4. You should get 4 binary digits. Means you should divide by 4 means 4. 2 2s are 4, remaining 0. Again 2 2 2s are 4, 2 1s are 2. So 1 0 0. You should continue this. So to the power of 4 means 0 0 0 1 1 0 1 9 1. So you should get this digit last here over here. So now x and y. So x and y is x plus y. Now x plus y. So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. So y and y plus x. So 0 y plus x is also same. 0, 1, 1 and 1. So this is how a truth table looks like for commutative law. So now same truth table, let us work for multiplication, x into y. Okay, x into y. So when you write for x into y, it is a multiplication. 0 0 0 0, 0 1 0, 1 0 0, 1 1 1. So it will be the same. So this is the truth table for commutative law. So hope you understood the commutative law. So next let us move to associative law. Associative law is a combination of both AND gate and OR gate. So when I say how does the associative is defined? So if x plus y plus z. Here if I make a group or a combination of this, it will be equals to x plus y plus z. This is the first way to define a commutative law using a OR gate. So when I use the AND gate, it represents as x into y into z, which is equals to x into y into z. So this is AND gate. AND gate. So let me go straightly to the truth table. After that I am going to come to the variables, how do I prove. So now I have three variables, means 2 to the power of 3 means which is equals to 8. So I should start my binary number from 0 to 7. So how do I do? Now x, y and z. Okay. So 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 and 1. So this is how we represent from 0 to 7. So next work is you should solve the bracket sums. So first bracket sums, y plus z. Okay. So y plus z. So 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 1. 0 plus 0 is 0. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1 is 1. So this is how your y plus z looks like. Next is this one, x plus y. So x plus y. So how do you write the x plus y now? So x plus y is been written as x plus y. So 0 plus 0 is 0. So 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 1 is 1. Okay. So 0 plus 1 is 1. 0 plus 1 is 1. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 0 is 1 plus 1 is 1. 1 plus 1 is 1. So this is the representation. Now what you should do? You should add First in the first column you should add x plus y plus z. So for y plus z you are going to add the x variables. So y plus z you are going to add the x variables. What has happened? 0 plus 0 is 0. 1 plus 0 is 1. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 1. 1, 1 and 1. So 1, 1 and 1. So next you should add, lastly is x plus y plus z. So how does it look like now? So now x plus y is this, and you should add z variable. So 0, so 0 plus 0 is 0. 1 plus 0 is 1. 1 plus 0 is 1. So 0 plus 1 is 1. So 1 plus 1 is 1. So 1 plus 1 is 1. So 0 plus 1 is 1. So 1 plus 1 is 1 and 1 plus 1 is 1. So check out your 1, 2, 3, 4, 5, 6. Your 6th and 7th column is almost same. So 6th and 7th column is almost same. So if it is like this, then we say this satisfies associative law. So anywhere if you get the equation, you can interchange that with this variable or this variable. This is the theorem of associative law theorem. So let us check for x into y. Now here I am just going to change them. This one, last three. I am going to change them. So anyhow you know x plus y. So now I am going to change that to x into y. First is y into z, right? So now let us see y into z. So y into z. So 0 0 is 0. 0 1 is 0. 1 0 is 0. 1 1 is 1. 0 0 is 0. 0 1 is 0. 1 0 is 0. 1 1 is 1. Next, x into y. So x into y. 0 0 is 0. 0 0 is 0. 0 1 is 0. 0 1 is 0. 1 0 is 0. 1 0 is 0. 1 1 is 1. 1 1 is 1. So next, what we should do? We should multiply x variable to yz. So x into yz. So x into yz. So 0 0 is 0. 0 0 is 0. 0 0 is 0. 0 0 is 0. 0 1 is 0. 1 0 is 0. 1 0 is 0. 1 0 is 0. 1 1 is 1. So next again x into y into z. Now what we should do? We should multiply xy into z column. So xy 1 0 0 is 0. So 0 1 is 0. 0 0 is 0. The 1 0 is 0. 0 0 is 0. 0 1 is 0. 0 0 is 0. 1 1 is 1. So here 6th and 7th column gets satisfied. So this is how you are going to prove that using a truth table. So let us now see how does the logical gate looks like. So logical gate. A logical gate for associative law is, so here first you should solve this bracket. Now what is this? Y z. So let us solve first for y and z. So y and z, it is in OR gate. So what do? I just draw the OR gate symbol. gate symbol as y plus z, and you are remaining your x is remaining out here, x is remaining out here, x, and what you do again, you are going to put the OR gate symbol. So OR gate symbol x plus y plus z. Okay. So next, what you should do again, you are going to write now again a logical gate. Write a logical gate now. So two tables. Now what you should write for x and y. Here z. So x plus y plus z. So x and y is common. So this is how you are going to write for OR gate symbol. So now, if you should write the logical gate for AND gate, means now how do you are going to write the logical gate for AND gate? You just change out the symbols over. That's it. So how do you change out the symbols now? So for AND gate. So for AND gate, you are going to write as, so AND gate symbol. So what you write? X, sorry, y into z. So here y into z. Again you have a x. So what you get? You get a AND gate over here. AND gate over here. So you write x into y into z. So yz is the column. So next, same way for next LRHS also, you have two variables. Here x into y. Here you get x into y into z. So this is how we are going to write the AND gate representation for a Boolean algebra or for a associative law. For associative law, you are going to write the Boolean algebra. So next, whenever you are going to use them for proof, how do you prove them? Prove them. Now let us prove this equation to both LHS and RHS. So here first x plus y plus z. So yz, which is equals to x plus y plus z. So now put x is equal to 0. So 0 plus LHS. So 0 plus y plus z. So yz, y plus z. Now RHS, put x is equal to 0 plus y plus z. So y plus z. So this is how you are going to show them. Now when I use x value, put x is equals to 1. So 1 plus y plus z. So y plus z. Again 1 plus y plus z. So is equals to 1 plus y is always it is equals to 1 plus z. Again 1 plus z is equals to 1 because we have already seen them through properties of Boolean algebra or Boolean algebra properties of 190. We have seen that any variable which is added to 1, then your remaining answer will be 1 itself. So again 1 plus y is 1 plus z. So 1 plus z is equals to 1. So this is how you are going to prove for AND OR gate. Now how do you prove for OR gate? So to prove to the OR gate, you are going to take the same equation with AND gate. So x into y into z is equal to x into y into z. So how now separate this LHS RHS. So x is put x is equal to 0. 0 into y into z. Anything you multiply by 0 is equal to 0. So now x into 0 into z. 0. 0 into z. Anything you multiply by 0 which is equal to 0. So 0 is equal to 0. So this is how you are going to prove the associative law. So hope you understood the associative law. So in tomorrow's video I am going to come across with distribution and absorption law. For till today this is enough. Thank you so much. If you have any doubts please contact me. Thank you.